In this lesson, we're going to be adding and subtracting rational expressions. And the first thing we need to remember is that we've got rational expressions going on here, which means we have fractions. And if you recall the rule when you are adding and subtracting fractions is that you require a common denominator. So that's the key. You need a common denominator in order to add and subtract fractions. So when we look at this rational expression here, you can see that we have two denominators. We have an x minus 2 term, and we have an x term. And we would look for things in common, but those are two completely different terms. Okay? So to get a common denominator, we can multiply those two denominators together. So as a common denominator, we're going to choose the common denominator of x and x minus 2. Okay, so let's look back at this original rational expression here. We've got 3 over x minus 2. And you have to ask yourself, what would I need to multiply that denominator by in order to make it x times x minus 2? And I think you can clearly see that we just need to multiply by x. Well, if I just multiply the bottom by x, I have changed this fraction. And that's why we're going to multiply the top by x as well. Okay, then we're going to subtract. And what are we subtracting? Well, we're subtracting 5 over x. Ask yourself, what do I need to multiply this denominator of x by in order to make it look like x times x minus 2? We can see that we need to multiply this fraction by x minus 2. Whatever we do to the top, or the bottom rather, we also do to the top so that we are not changing the fraction. All right, well, let's go ahead and do this multiplication, and then we'll rewrite the line. Now, careful here. We've got 5 times 2, or rather x, and 5 times negative 2. So, up top here, we've got 3 times x, 3x. Down on the bottom, we have x times x minus 2, which is our new denominator. We are going to subtract, well, 5 times x is 5x, and 5 times negative 2 is negative 10. All of that over the exact same denominator, x times x minus 2. Well, now that we have a common denominator, we can combine both numerators over top of the common denominator. So we've got 3x minus 5x, and then minus negative 10, which, careful, is going to be plus 10. All of that over the common denominator of x and x minus 2. And we can combine the like terms of 3x and 5x to get negative 2x plus 10. And all of that is over top of, again, x and x minus 2. Now, are we done? Well, I'm going to suggest that there's one more step we can do. If we look at the top, we realize that we can take out a common factor of negative 2. So I'm going to do that. I'm just going to take out a negative 2, which would mean that we are left with an x, and I'm going to be careful with the sign here, minus 5 over top of x and x minus 2. Okay, so there we go. We were asked to simplify a rational expression that involved subtraction. We need to find a common denominator first. Once we have the terms with common denominator, we just combine the numerators and make sure we simplify at the end. we do not expand this denominator back out and remove the brackets. Simplifying adds brackets in. Expanding removes the brackets. So leave well enough alone. All right, let's try a different one. What if we were asked to simplify this rational expression? Well, again, we have two fractions being added together, and we know that when we are adding fractions, we need a common denominator. Okay, well, what do we choose as the common denominator? Well, it's a little hard to tell right now, and the reason why it's difficult to tell is because of this denominator here on the right side. It is a trinomial. And in order for us to choose a common denominator, we need to express it in factored form. We want to have all of our terms involved with multiplication. So I'm just going to rewrite this expression, and the first term is fine. It has an x plus 5 term on the bottom. The second, however, is not. So what I'm going to do is I'm going to take a look at this simple trinomial, and I'm going to try and factor it. And sure enough, I look at this and I realize that two values that multiply to give me 20, that also add to give me 9, would be x plus 5 and x plus 4. Okay, so what do I choose as a common denominator? Well, if I notice that the first fraction has the denominator of x plus 5, the second fraction has an x plus 5 and an x plus 4. So if I choose a common denominator of x plus 5 and x plus 4, the second denominator, you will see that that will mean I do not need to change the second fraction's denominator. The only fraction that I need to change will be the first one, because it does have an x plus 5 term. It's just missing the x plus 4 term. Well, that means that the next line I write, I could just say, all right, take x plus 4 over x plus 4, and we're going to multiply that into that first fraction. So over x and x plus 5. I do not need to change the denominator in the second fraction at all. So x plus 5 and x plus 4 is already the denominator there. So now I have a common denominator with both fractions. I'm going to be careful with my multiplication up top here. I've got a binomial and a monomial. So the first fraction is going to give me an x squared plus 4x. All of that over x plus 4 and x plus 5. And this is a 4 all over x plus 4, I'll put the 4's first, and x plus 5. Perfect. Okay, well, let's combine the numerators now. And I notice that when I combine them, I get x squared plus 4x plus 4. Well, x squared plus 4x plus 4 over x plus 4 and x plus 5. Well, that can be simplified as, I'm going to look at the top now, that's x plus 2 squared, because that is a perfect square, over top of x plus 4 and x plus 5. So there's the final answer. So remember, when you are adding fractions, you need a common denominator. You don't necessarily always need to change both denominators, because if one of the denominators already includes all of the terms you require, you will only need to change the other denominators to match the larger one.